Good morning, students. So, hello all again. This is lecture number 3. Okay, preparation methods. So, already we are discussed about some preparation methods from alkanes. Okay, from alkenes. Okay, so here from alkenes, second method. Okay. Second method from alkenes. Okay, from alkenes. So first, hydrohalogenation or addition of HX. Addition of HX. So second one, halogenation or addition of X2. So this is already discussed in earlier session. So now discussion this preparation method. Okay, this preparation method. So first, so second preparation method from alkenes, addition of HX. Sorry, addition of X2. Addition of X2. So I can take here alkene CH. So propane, this is a propane, it is unsymmetrical alkene. So here Br2 and CCl4. So which product is obtained? Okay, which product is obtained? So generally alkyl halides are obtained in this reaction. So here I can write mechanism. Okay, so here CH3. So this is the one propene. So here this is the non-polar solvent. CCl4 is non-polar solvent. So bromine is there. Okay, Br. Okay, Br. So here electronegativity difference between the bromine atoms is 0. Electronegativity difference is 0. So this is the electron rich species. Alkene is electron rich species. So here these electron displacement towards the bromine. Okay, these electron displacement towards the bromine. Okay, again these electron displacement towards this bromine get partial negative charge, this bromine gets partial positive charge. Okay, partial positive charge. So we get whenever these electron displacement towards this bromine, so Br minus is leaved, so we get Br minus. Okay, Br minus. So here CH3 and CH2 Br. So here electron displacement towards this carbon. So that's why this carbon gets positive charge. Okay, positive charge. So whenever the positive charge on this carbon, that is the primary carbocation. Whenever the positive charge on this carbon, this is a secondary carbocation. So generally secondary carbocation is more stable than primary carbocation. That's why electron displacement towards this. Okay, so this is a positive charge. Again here bromine has 3 lone pairs. So this lone pairs donated to here. So we get CH3, CH and CH2. So bromine gets positive charge. So bromine get positive charge. So this is the bromonium ion. Okay, bromonium ion, okay, bromonium ion, or non-classical carbocation, or non-classical carbocation, non-classical carbocation, okay, non-classical carbocation. So now here Br minus is leaved. So Br minus is a nucleophile. Okay, Br minus is a nucleophile. So Br minus is nucleophile. Then Br minus. So this is a positive charge. Bromine has positive charge. That means electron displacement towards carbon. So here partial positive charge. Here also partial positive charge. So this nucleophile attack on either this carbon or this carbon. So here this is a more stable carbocation, so that's why nucleophile attack on here. So we get CH3 Br, then CH2 Br. Okay, so here electrophile positive species attack on below the plane. So next to negative species attack on above the plane. So that's why this is the anti-addition. Okay, anti-addition. So anti-addition takes place. So in this reaction anti-addition takes place. Okay. So halogen, in presence of any halogen, alkenes undergoes to anti-addition takes place. This is the non-polar solvent. This is the mechanism. Okay. So in this reaction, which is the intermediate, carbocation is the intermediate. Okay, carbocation is intermediate. Okay, so next one more question, one more example. So one more example. So I can take CH3 CH double bond CH2. So this is a propene. So here Br2 and CCl4. So just a minute, I can change the solvent. So here polar solvent is there. Okay, polar solvent is there. So which product is obtained? Which product is obtained? So here similarly, so I can write mechanism CH3 and CH. So this is the propene. So Br and Br. Okay. So whenever this electron's displacement towards this carbon, this electron moves towards bromine. Bromine partial negative charge. This is the partial positive charge. So we get, so here Br minus is leaved. Okay, Br minus is leaved. So we get CH3 CH and CH2 Br. So this carbon gets positive charge. So here we can use it as polar solvent. Okay, polar solvent. In presence of polar solvent, so in presence of polar solvent, in this reaction polar solvent acts as a nucleophile. So here bromine also is nucleophile. Whenever the non-polar solvent to bromine attack this carbon, so if polar solvent present, polar solvent that attack on the carbocation. Okay, carbocation. So which is the polar solvent? H2O. So H2O contains two lone pairs. Because of it is act as a nucleophile. Electron rich species are called nucleophile. So nucleophile attack on electrophilic center. So we get so oxygen gets positive charge. So oxygen gets positive charge. So here oxygen is electron donor, that's why oxygen is a positive, oxygen containing positive charge. If positive charge on more electronegative element will be unstable. So here positive charge, oxygen is the electron donor, that's why it gains the positive charge. So whenever the more electronegative element contain the positive charge, that will be unstable. So that's why electron displacement towards the oxygen. So we get here OH and CH2 Br. Okay, CH2 Br. So here H plus ion is released. So this H plus ion, here Br minus ion is released. So both are combined to give byproduct eliminated as HBr. So if you are using the non-polar solvent, we get halogen compounds. We get the dihalogen compounds. We get dihalogen compounds. So here we are using the non-polar solvent, we get dihalogen compounds. So dihalogen compounds generally two types. Okay. So whenever the two halogen atoms present on the same carbon atom, that is a gem dihalide. So here two halogen atom present on the adjacent carbon. This is a one carbon, this is another carbon. So that's why this is a vicinal dihalides. Okay, vicinal dihalides. If two halogen atoms present on the same carbon, that is a geminal dihalide. If two halogen atoms present on adjacent carbon, that is called vicinal dihalides. Okay, in presence of non-polar solvent, alkenes react with halogen to produce vicinal dihalides. Okay, vicinal dihalides. Okay, vicinal dihalides. So whenever the halogen addition to the alkenes to produce hydroxy compounds in presence of polar solvent, in presence of polar solvent. So I can write one more compound. Okay, one more compound. So similarly, I can take propene, CH double bond CH2. Okay, propene in presence of so I can take Br2. Okay, Br2 and NaCl. Okay, NaCl. So Br2 addition of halogen, and sodium chloride is a polar solvent. Okay, polar solvent. So because of electronegativity difference between between chlorine and sodium atom. So that's why this is a polar atom. So in presence of polar molecules, so what will happen? So I can write mechanism CH3 CH double bond CH2. So this is the propene. So here Br bond Br. So here there is electron displacement towards here, electron displacement towards bromine, Br minus and Br plus. So we get CH3 CH2 Br. So this then positive charge. Okay, so here Br minus is labeled. Then second step, if you are using the non-polar solvent, this Br minus attack on the positive charge. But here we are using the polar solvent. In polar solvent, which is a nucleophile, Cl minus and Na plus. Cl minus is a nucleophile. So Cl minus attack on positive charge. So we get this compound. We get this compound. Okay. So if you are using the non-polar solvent, we get 1, 2 dibromopropane. So but here 1 bromo 2 chloropropane. So because of you are using the polar solvent. Okay, polar solvent. I can use one more example. I can take one more example. So this is an example. So I can take Br2 and CCl4. So here non-polar solvent is here. Okay, non-polar solvent is here. So we get, so which product is obtained? Okay, which product is obtained? So Br and Br. So these electron displacement towards here. Okay. So we get Br. So here Br minus is levered. So this carbon gets positive charge. This is the tertiary carbocation. So then So here we can use it the non-polar solvent. Okay, non-polar solvent. So that's why Br minus. Okay, Br minus attack on backside. Okay, so this is an anti-addition takes place. Okay, anti-addition takes place. Br and Br, anti-addition products. Okay, so next I can take one more example. Similarly, I can change the solvent. So here Cl2 HCl, sorry, H2O. So this is the polar solvent. Okay, polar solvent. So here Cl and Cl. So this pi electron displacement towards here is eliminated as nucleophile. Okay, so we get Cl, this carbon gets positive charge. So here we can use it the non-polar solvent. So non-polar solvent acts as a nucleophile. So nucleophile attack on electrophilic center. So here anti-addition takes place. Oxygen gets positive charge because of oxygen donate the electron to the carbocation. Oxygen gets positive charge. If more electronegative element containing positive charge, that will be unstable. So that's why electron displacement towards oxygen. So we get hydroxy product. So chlorine hydroxy product. So here this H plus ions combined with Cl eliminated as HCl as a byproduct. Okay, so this is a preparation of alkyl halides from alkenes. So first method addition of HX, second one addition of halogens. Okay, next third preparation method. Okay, third preparation method from alkynes. From alkynes. Okay, from alkynes. So here also two methods are there. So first one, addition of HX, addition of HX. So it is also called as hydrohalogenation. Okay, hydrohalogenation. Okay, second one, addition of X2, halogen. Addition of X2. Addition of X2. So now we are discuss this method addition of HX. Okay, so from alkynes, substrates are alkynes. I can take alkyne, CH triple bond CH. So this is a alkyne. Okay, so alkyne. Okay, in addition of HX in presence of CCl4, non-polar solvent. So which products are obtained? Okay, which product are obtained? So here, so first I can write mechanism. Okay, so these are the alkynes. Alkynes also alkynes are participate in electrophilic addition reaction. That means this reaction initiated by the electrophile. This reaction initiated by the electrophiles. I can take here HX. So H is partial positive charge. This is the partial negative charge. Which is the electrophile? This is the electrophile. So here this electron displacement towards here, this carbon gets negative charge. So this carbon gets positive charge. Therefore H plus ion attack on here. So we get CH2 double bond CH. This carbon gets positive. So again here X minus is there, this X minus attack on here, so we get CH2 and double bond CHX. So this is a vinyl halide, okay, vinyl halide. So I can use 1 mole of HX, 1 mole of HX, okay, 1 mole of HX. So here two possibilities is there. So electron displacement towards here, one possible, electron displacement towards another possible. So this is the possibility A, this is the possibility B. So I can write first possibility A. Possibility A. So possibility A, just a minute. I can write possibility A. So possibility A, electron displacement towards this carbon, this gets negative charge, this gets positive charge. Okay, this gets positive charge. Okay, so next to possibility B. Possibility B, so this gets positive charge, this gets negative charge. So here chlorine has 3 lone pair atoms. So here also chlorine has 3 lone pair atoms. So which structure is more stable? Among these two structures are more stable. So here this compound participate in resonance and due to the partial double bond character. So but here this is the negative, this is the lone pair. Electron density, more repulsion arises between the negative and positive. So that's why this is a not feasible, this is a feasible. So that means H plus ion attack which carbon? This carbon. Okay, H plus ion, A possibility is correct, so B possibility is wrong. Okay, the H plus ion attack on here. Okay, so this carbon get CH3. Okay, next CHX minus. Okay, X plus, electron displacement towards here, X plus. Okay, then so this is a chlorine has minus I group. Minus I group decrease the stability of carbocation atom, but mesomeric effect is dominates than resonance is dominates than inductive effect. So here H plus ion attack on here, remaining X minus is there. So this X minus attack on here. So we get CH3, CH, X and X. So which product are obtained in alkynes? So these are the alkyl halides, but this alkyl halide is gem dihalides. So gem dihalides means this, if two halogen atoms present on the same carbon, that is the gem dihalides. Okay, gem dihalides. So next I can take one more example. Okay, one more example. So unsymmetrical alkyne. Unsymmetrical alkyne. So addition of HX in presence of CCl4. In presence of CCl4. Okay. So which product is obtained? I can write mechanism. CH3C triple bond. So this is a propyne. Okay, propyne. So here HX. Hydrogen is less electronegative compared to the halogen. So that's why this gets partial positive, this gets partial negative. Okay, partial negative. So here alkynes are participating electrophilic addition reaction. That means this reaction initiated by the electrophile. So among this, which is the electrophile? H plus ion is the electrophile. So here also two possibilities is there. So one electron displacement towards here, this is the A possibility, and electron displacement towards here, B possibility. Okay, so I can write here CH, A possibility, double bond CH, So A possibility, this carbon gets negative charge. Okay, so this carbon gets positive charge. And B possibility, so I can write CH, C double bond CH. This carbon gets negative charge, this carbon gets positive charge. So among these two possibilities, which is the most stable? So second one is the most stable. So because of this is the plus I group. Plus I group increase the stability of carbocation. So here this is the plus I. Plus I decrease the stability of carbon. So which is the more feasible? So which is the more feasible? Second one, B is the more feasible. Okay, reaction mechanism refers to B. So here H plus attack on this carbon. So H plus attack on this carbon. So we get CH3 just a minute. C triple bond, just a minute. So this carbon has positive charge. Okay, this carbon has positive charge. So here remaining part X minus. So X minus attack on here. So we get CH3 X double bond CH2. Okay, CH2. So again react with HX. This is a partial positive, this is a partial negative. Okay, partial positive and partial negative. So again this positive ion attack on here, this negative one attack here. So we get CH3 C X X and CH3. Okay, CH3. So this is also gem dihalides. Okay, gem dihalides. So two halogen atoms are present in the same carbon. This is also gem dihalides. Okay, next one, preparation of alkyne halides from alkynes. So second method addition of X2. Addition of halogen. So I can take here CH3 C triple bond CH. So here Br2 and CCl4. So the product is obtained. I can use here 2 moles. Okay, 2 moles of bromine. So we get addition takes place. So first bond breaks, triple bond breaks, C single bond CH. Okay, here first bond removed. So 1 Br. So next to second bond breaks, Br. Okay, so this is a 1, 2, 2. Sorry, 1, 2, 3. So 1, 1, 2, 2 tetrabromoethane. Okay, tetrabromoethane is possible. So I can take one more example. CH3 C triple bond CH3. So here also, so 2 Br2 and CCl4. So here first we get product CH3. Okay, so first bond breaks Br. So next to second bond breaks, Br. So the compound name is 1, 2, 3, 4. Okay, 2, 2, 3, 3, tetrabromobutane. Okay, tetrabromobutane. So this is a preparation methods of alkyl halides from alkynes. Okay, from alkynes. So next method from alcohols. Okay, this is the important one. From alcohols, preparation methods. Alcohols to alkyl halide. Alcohols to alkyl halide. So here I can take, so here two methods is there. So first one, alcohols react with ZnCl2 plus HCl. So second one, NaBr plus H2SO4. Next to third one, alcohols react with PCl5. So next to fourth one, alcohols react with PCl3. Next to fifth one, alcohols react with SOCl2, sulfonyl chloride. So we know that this is a famous reaction, Darison reactions. Okay, this is a Darison reaction. Darison's reactions. Okay, Darison reaction. Okay, Darison reaction. So here this is the famous test for identification of alcohols, Lucas reagent. Okay, Lucas reagent. So Lucas reagent. Okay, Lucas reagent. So these are the 5 methods preparation of alkyl halides from alcohols. So now discuss about the Lucas reagent. Okay, Lucas reagent or ZnCl2, Lewis acid plus HCl. Okay, HCl. So Lucas reagent. So here first I can take ZnCl2 act as a Lewis acid. ZnCl2 act as a Lewis acid. So here HCl. Lewis acid which can accept the Cl minus. ZnCl3 plus. So ZnCl3 minus and H plus. Okay, H plus. So here I can take one alcohol, so CH3, CH2 and CH2OH. So this is a propanol. So here H plus ion is there. Okay, H plus ion. So H plus ion in the sense Lewis acid, empty orbital is there. So here alcohol, oxygen containing lone pairs. So this lone pairs donated to here. So we get CH3 and CH2 and CH2. Oxygen gets positive charge. If more electronegative element contains positive charge, that will be unstable. So that's why here we are using some heat also. Heat, it supposes the entropy. Okay, it supposes the entropy. So generally entropy, gaseous molecules are more than liquids, more than solids. Due to the support of entropy, so water molecule is eliminated. Electron displacement towards oxygen. So water molecule is eliminated. So CH3, CH2, we get carbocation. So water molecule eliminated, we get carbocation. So any reaction, if carbocation formed as intermediates, in that reaction carbocation rearrangement takes place. The rearrangement takes place. That means less stable carbocation rearranges to more stable carbocation. So here this is a primary carbocation. So generally primary carbocation is less stable when compared to the tertiary carbocation. So that's why here hydride ion, one hydride ion displacement towards, okay, one hydride ion displacement towards here. So I can write another way, just H CH, so I can write here H. This hydride ion H minus shifted to here, so we get CH3, okay, CH and CH3. This carbon gets positive charge, okay, this carbon gets positive charge, okay, this carbon gets positive charge. So here Zn Cl Cl Cl, the negative. This Cl minus ion attack in here, Zn Cl, this Cl minus attack on here, so we get Cl and CS. This is the 2-chloropropane. This is in the form of PPT. Okay, PPT. So here, which compound formed as an intermediate carbocation? So in this reaction, rate of reaction depends on stability of carbocation. Okay, stability of carbocation. So rate of reaction is directly proportional to, okay, rate of reaction. Rate of reaction is directly proportional to stability of carbocation. Stability of carbocation. Rate of reaction is directly proportional to stability of carbocation. So here I can use the primary alcohol. Okay, I can use primary alcohols. So RCH2 OH. So this is a primary alcohol. I can use secondary alcohol. So next I can use tertiary alcohols. So this is a tertiary alcohol. So which alcohol is more reactive towards Lucas reagent? So which is the more reactive? So here our mechanism, so OH minus is leaved. So OH minus is leaved, we get primary carbocation. OH minus leaved secondary carbocation. OH minus leaved, we get tertiary carbocation. Which is the most stable carbocation? Which is the most stable carbocation? Tertiary carbocation is more stable. Okay, so that's why tertiary alcohols more reactive with Lucas reagent. Tertiary alcohols more reactive with Lucas reagent, and the rate of reaction is directly proportional to stability of carbocation. So in these three compounds, this is the tertiary carbocation, this is the secondary, primary. So which is the most stable? Tertiary carbocation is more stable. So that's why tertiary alcohol are more reactive with Lucas reagent. So here rate of reaction tertiary alcohol, then secondary alcohol, then then primary alcohol. So I can take one test tube. Okay, one test tube. Inside the test tube, inside the test tube, tertiary alcohol is there. Okay, tertiary alcohol is there. We are added to Lucas reagent ZnCl2 plus HCl. So white PPT. So PPT is appeared. So generally PPT is appeared in just 1 minute. That is a tertiary alcohol. So 1 minute, that is a tertiary alcohols. In case 5 minutes, that is the secondary alcohol. In case 30 minutes, okay, 30 minutes in the sense half an hour, so primary alcohol. So by using Lucas reagent, we can separate the primary, secondary, tertiary alcohol. So by using Lucas reagent, we can prepare alkyl halides. Okay, alkyl halides. So among these three alcohols, which is the more reactive? So tertiary alcohol is more reactive because of it forms more stable carbocation. That is a tertiary carbocation. Okay, tertiary carbocation. So in this reaction, ring expansion also possible. So because of in this reaction, carbocation formed as intermediate. Okay, carbocation formed as intermediate. So I can write just one more example. Okay, so this is the alcohol. So generally alcohols react with Lucas reagent, ZnCl2 plus HCl, Lewis acid plus HCl, Lucas reagent. Okay, so in this reaction, which compound formed as intermediate? Carbocation. So carbocation intermediate. So this is the, I can write just this provide the H plus ion. So H plus ion attack on here. So oxygen gets positive charge. If more electronegative element has positive charge, that will be unstable. So electron displacement towards oxygen. So we get, sorry, just a minute. H plus ion attack on oxygen. Oxygen gets positive charge. This is the unstable electron displacement towards here. Water molecule is eliminated. Okay, due to the support of entropy. In this reaction, we can use heat also. Okay, H2O molecule eliminated is there. So this is the carbocation. This carbocation is stable or unstable? So here carbocation rearrangement is possible. Okay, carbocation rearrangement is possible. The less stable carbocation rearranges to more stable carbocation. In this carbocation, how many number of alpha hydrogens is there? So this is the system adjacent carbon is alpha carbon. Just wait. System adjacent carbon is alpha carbon. This is also alpha carbon. Okay. So here 2 alpha hydrogens is there. Here also 2 alpha hydrogens. So total alpha hydrogens are 4 alpha hydrogens. So here in any reaction, carbocation formed as intermediate. In that reaction, carbocation undergoes to rearrangement. That means less stable carbocation rearranges to more stable. So here this hydride ion shifted to here. So we get this carbon gets positive charge. So in these compounds, how many number of alpha hydrogens are there? So alpha hydrogens equals to this is the alpha carbon, system adjacent alpha carbon. This is also alpha carbon. Here how many number of alpha hydrogens is there? 2 alpha hydrogens. Here how many alpha hydrogens is there? 3 alpha hydrogens. So total 5 alpha hydrogens. Okay, 5 alpha hydrogens. So which is the most stable? 5 and 4. This is the most stable. So that's why rearranges to here. So then nucleophile. So we know that already mechanism. So nucleophile into Cl minus, H plus already used, then Cl minus. This Cl minus attack on here. So we get Cl. Okay. So in case Cl attack on here, we get attack on here Cl. So which one is the right? So this is the wrong one. So this is the right one. So because of less stable carbocation rearranges to more stable carbocation. So in our examination 2 options are there. Okay, 2 options also present. But which is the most stable? First one is the most stable because of this carbocation is more stable. Okay, carbocation is more stable. So next I can take one more example. One more example. One more example. So here ZnCl2 plus HCl. So this is also Lucas reagent. So which product is obtained? Okay, which product is obtained? Suppose examiner asking, so option 1 Cl. Okay, so next option 2 Cl, option 3 Cl, okay, option 4 Cl. Okay, so which is the product is formed? Okay, so we know that mechanism. So generally HCl, ZnCl2 is Lewis acid. Okay, Lewis acid, that means empty orbital. So here HCl is Cl minus and H plus. This Cl minus is accepted. ZnCl3 minus and H plus, and H plus. H plus is Lewis acid because of empty orbitals. So here, so I can take substrate. So here OH minus. So this H plus ion. This H plus ion has empty orbital. So here oxygen has lone pairs. This lone pair donated to the empty orbital of proton. So we get, so then oxygen gets positive charge. Okay, oxygen gets positive charge. Okay, so we know that if more electronegative element containing positive charge, that will be unstable. So that's why electron displacement towards oxygen. So here heat also is supported in that reaction. So due to the support of entropy, if you are increase the temperature, entropy also increases. So in this reaction, entropy is supported. So that's why water molecule is eliminated. So water molecule is eliminated. So here water molecule is eliminated. We get carbocation. So we know that 6-membered ring is more stable than 5-membered ring. Okay, 6-membered ring is more stable than 5-membered ring. So that's why here ring rearrangement. Okay, ring rearrangement takes place. Okay, so first I can give numbers. So this is the first one, second, third, fourth, fifth, sixth. Okay, so rule 1. So bond making between 1 and 3. So 1 and 3. Bond making between 1 and 3. Bond breaking between 2 and 3. So and charge shifted from first position. This is the first, second, third. First position to second position. So we get a new compound. Okay, we get new compound. So here bond formed between the 1 and 3. Okay, charge shifted from second position. Okay, second position. So here, so I can write a 6-membered ring. So totally 6-membered ring, 1 methyl group. Okay, 6-membered ring. So here, this is the first carbon containing methyl. Okay, methyl group. So first carbon connected to third and second carbon. This is the first carbon. This is the first carbon. So first carbon connected to third and second. This is the second. This is the third. Third connected to fourth. 4 connected to 5. Okay, 5 connected to 6. Okay, 6 connected to second carbon. Okay, so charge shift from first position to second position. These are the rules. Okay, second position. So here this is the secondary carbocation. So generally tertiary carbocation is more stable than secondary carbocation. So here one hydrogen is there. So this hydride ion shift takes place. The hydride ion shift takes place. So we get stable tertiary carbocation. So we get stable tertiary carbocation. This is the carbocation. So because of H minus shifted to here, this carbon gets positive charge. then so here Zn Cl3 minus, so here Cl2 attack on here, so we get this product. Okay, this is the correct answer. Okay, so this is the preparation methods of alkyl halides. Some more preparation methods are there, so I will discuss next session. Thank you everyone.